there remains the question: why do the thermodynamic and cosmological arrows point in the same direction? Why does disorder increase in the same direction of time as that in which the universe expands? If one believes that the universe will expand and then contract again, this becomes a question of why we should be in the expanding phase rather than the contracting phase. One can answer this on the basis of the weak anthropic principle. Conditions in the contracting phase would not be suitable for the existence of intelligent beings who could ask the question: why is disorder increasing in the same direction of time as that in which the universe is expanding? The inflation in the early stages of the universe implies that the universe will not recollapse for a very long time. By then all the stars will have burned out, and the baryons in them will probably have decayed into light particles and radiation. The universe would be in a state of almost complete disorder, or thermal equilibrium. There would be no strong thermodynamic arrow of time. Disorder couldn't increase much, because the universe was in a state of almost complete disorder already. However, a well-defined thermodynamic arrow is necessary for intelligent life to operate. Human beings have to consume food, which is an ordered form of energy, and convert it into heat, which is a disordered form of energy. Thus, intelligent life couldn't exist in the contracting phase of the universe, but only in the expanding phase. This is the explanation of why we observe the thermodynamic and cosmological arrows of time to point in the same direction. It is not that the expansion of the universe causes the thermodynamic and psychological arrows of time. Rather, the no-boundary condition causes there to be a thermodynamic arrow. This arrow is well defined, and it agrees with the cosmological arrow in those regions of spacetime in which there are people to notice whether they agree. To summarize, the laws of physics do not distinguish between the forwards and backwards directions of time. However, there are at least 3 arrows of time which point a direction in time and which distinguish the past from the future. They are the thermodynamic arrow, the direction of time in which disorder increases; the psychological arrow, the direction of time in which we remember the past and not the future; and the cosmological arrow, the direction of time in which the universe expands rather than contracts. I showed that the psychological arrow was determined by the thermodynamic arrow, and that the two would always point in the same direction. The no-boundary proposal for the universe implies that there will be a well-defined thermodynamic arrow of time, because the universe will start in a smooth and ordered state. The reason we observe this thermodynamic arrow to agree with the cosmological arrow is that intelligent beings can exist only in the expanding phase. The contracting phase will be unsuitable because it doesn't have a strong thermodynamic arrow of time. If you have remembered every word I said, your memory will have recorded about 150,000 bits of information. Thus, the order in your brain will have increased by about 150,000 units. However, while you have been listening to me, you will have converted about 300,000 joules of ordered energy in the form of food into disordered energy in the form of heat, which you lose to the air around you by convection and sweat. This will increase the disorder of the universe by about 3 times 10 to the 24 units, about 20 million times the increase in order, because you remember my talk. I think, therefore, I better stop now, before we degenerate to a state of complete disorder. The velocity of light is 1 by definition. Light travels 1 light year in a year. But the effect of baby universes can make other constants appear different.
Light is the one fundamental constant that is indeed fixed at unity in physicist units. There is a band rehearsal here soon. We've learned our lesson. The next time we invite Professor Hawking, it will be in the Greek theater. One more thing. The questions are really extremely good ones, and I've been thinking here how to continue this, and we are reluctant to see Professor Hawking leave, so my suggestion is that if you could mail to the astronomy department your questions, we will see that Professor Hawking gets them, and if he's willing and wants to expand his audience even more, we will publish the answers in the Daily Californian. Thank you very much.